Okay, so this video is going to be very, it's going to be conceptual. So you're going to want to pay attention to the hand motions and also the drawings that I put on the board. Okay, so a little recap. Okay, we said that an electric current produces a magnetic field. Okay, so let's just write that down. Electric current produces a magnetic field. Okay, and then the opposite goes to a magnetic, and I'll abbreviate here. Magnetic field produces an electric current. So we can get a moving magnetic field to produce an electric current. And then we all also know that an electric current produces a magnetic field. Okay, so very important. Two important things to know is that you can switch them back and forth. And a little background information is that moving magnets produce electric fields. So to produce electricity, we can all we have to do is move magnets. So that's a little bit later on, but we're going to learn a little bit about generators and such. Okay. Okay, so here's where it gets a little tricky. I'm going to do the best I can. All right, so we've got directions, right? We've got the X direction, we've got the Y direction, and we've got this thing called the Z direction, which you really haven't talked about that much. Okay, so we know X direction, right? We know that X can be either this way or this way. All right, that's simple enough. Y can be this way or this way. Okay, the Z is a bit more complicated. Okay, because now we're looking at something that's going into the paper or out of the paper. Okay, so you're either going into the paper or out of the paper. Okay, in our Z direction. Okay, and this is all going to come together in a few minutes when we talk about magnetic fields. So look, I've got X direction figured out. I've got Y direction figured out. The Z direction, we need a way to identify that. So I'm going to draw something here. Okay, you're going to need to draw it because it actually makes a lot of sense when you think about it and you draw it. So the Z direction, I'm going to draw a picture of an arrow. Okay, this isn't a physical arrow, like one that I would shoot out of a bow. Okay, here's the feathers on there. Okay, you got the feathers, you got the arrow, so you got the feathers on the back, the arrow in the front. So let's say I took that arrow and I shot it down into the paper. So I go into the paper. So if I shot it into the paper, the tail would leave little marks like this into the paper. Okay, now I'm going to draw quite a few of them. Obviously, this would take 16 arrows to make this matrix. But if I were to take an arrow, shoot it into the paper, it'd leave a mark in the paper like this, because the tail would leave two little slits in the paper. Okay, so anytime I represent something that moves into the paper, it's going to look like this. Okay, into the paper. Now, this is the only, this makes physical sense. Because look, the arrow, as it goes through the paper, rips a hole in the paper, but rips a hole in a way that follows the feathers. Now, the other way is only one other way to go, out of the paper. Okay, so we're gonna draw something that represents out of the paper. Okay, this represents some arrow that's popped through the paper, out of the paper at you. We'll say out of. Okay, so the dots represent out of, the plus signs represent into. Okay, I'm going to give you a little quick quiz right now. Okay, we'll let you write down that the notes. So X is easy to write, Y is simple to write. The Z direction, you got this arrow A physical arrow going into and out of. Okay, I'll let you write that down. Okay, so you remember how I said that if you have your thumb pointing in a certain direction, that's the direction of the electricity flow? Okay, so the electricity is flowing this way. That means that the B field is wrapping around it with the curve of your fingers. Okay, so the curve of your fingers gives you that B field. So look, if I were to do this and show, and I'll draw a picture here. Look, here's a picture. There's the current flowing through a wire. Now, we know that this, I'm going to try to draw it three-dimensionally. This produces a B field, which wraps around itself this way, whoop, like that. Okay, so look. This produces something that looks, I'll try to draw it for you. It kind of looks like this. Okay, that's probably the best I can do. Okay, so look. Here, now I just know this by the right hand rule. Current flows like this. So it wraps around, the B field, the magnetic field wraps around this way. Okay. Now, if I were to take a sheet of paper, okay, and draw this like this, and let's lay this wire on a piece of paper. Now, because now if I had a piece of paper, it would be like in back. Like you wouldn't see this part of it right here. You wouldn't see that part. You only see like this part. So look, here's the paper. It comes out of the paper, and I'll say that again. It comes out of the paper. Okay, there it is, out of the paper. And then goes around. Hey, look at the picture. Goes around and back into the paper. So a correct drawing for the direction of the magnetic field would be, here's your current, okay, flowing out of the paper and back like this, back into the paper. Out of the paper, back into the paper. So this up here is a correct statement. Now, I'm going to flip that around for you. This can be it can be challenging, but once you got it, it's pretty you got it. So look, I got a current flowing this way. Okay, now I got my thumb. Okay, now you can't see the curl of my fingers, but my thumb is going to point towards the direction of this arrow right here. Arrows this way. That means that, I don't know if you can see that, into. So the top part would have into, which are X's or pluses. And the convention actually is to draw pluses. I tend to, and a lot of other physics people tend to draw X's. X's or pluses work just fine. It shows that the arrows, the arrow going into the paper, is just a tail here. So look, this way, into. So the top of this would be into. So the B field is going into the paper, and then when it's coming around, it's going out of the paper. So look, into the paper, and then it's coming back around. I know it's hard to see, but it's coming back out of the paper. So let's see if I can do that. Out of the paper and into the paper. Okay, this can be a difficult concept to understand. I'll do a couple more here. Okay, I'll do one where the field is going up. So look, field's up. That means that the B field, the magnetic field, is going like this. So if it's going like this, this has to be the into side. Okay, into, and then it goes around and comes out of this side. Okay, the into, the out of. Okay, we'll let it sit there. That's about 10 minutes. let's take a break from this stuff.